Hi everyone. I hope all of you are doing well. Welcome back. So in this video, we will go over chapter 2. It's called Communicating Over the Network. The first thing I want all of you to do is go and watch all the videos that are present on this slide. I will post the links for all of them in the description. So you need to watch about 4 videos. They're very small videos, like probably 6 to 7 minutes long, but they're very cute. I promise you'll love them. Just go and watch those and then come back to this video. For now, I'll pretend that you have watched the videos and you've done as I said, and you're back after watching the videos. So moving on, when we communicate with anyone, let's say you're talking to your friend, there's in any form of communication, there are 3 common things. Okay, the first one is basically the sender. So the person who is talking is called the sender or the source. All right. The second thing is, the second thing is the receiver or the person you're talking to. They're also known as source. Okay. And then they're also known as destination. And the third one is the media or is basically the medium that you're choosing to communicate in. So that could be like there are different mediums that you can use for your communication. You can speak or you can look. Sometimes you communicate by looking. This especially happens when students are cheating in exam. Or you can have gestures, signals, hand signals, or even body movements. These are the different ways people choose to communicate in. So the 3 things that are common are basically source or the sender, destination or the receiver, and the third one is the medium. All right. Now, the devices on a network communicate in a similar fashion. Okay, so here I can see that there is basically a source which is sending the message. Then there is a destination which is supposed to receive the message. All right, and between these two, the source and the destination, there are several things which we will look at now. So once the message is generated or created, what happens is the device, or let's say the source, encodes the message. Okay, it takes the message and changes it into the form that can be transmitted over the network. If you're using a wired connection, let's say you have an Ethernet connected to your computer, then the encoder will generate signals. All right. But if you're connected to a wireless connection, let's say Wi-Fi, then the encoder will encode your message into waves. So based on whichever medium you have, the encoder will encode your message into that particular format. All right, and then the transmitter will take the signal or the wave or whatever was generated. In this case, it's actually we are actually thinking that you're connected using using a wired connection. So what would happen is the transmitter would take that signal and then transmit it over the medium. In this case, the medium is this black wire. It's basically a cable in this case. Okay. So the transmitter takes all those signals and then the transmission happens, which is nothing but sending your message um, across to the destination using the medium. And then on the destination end, there is a receiver, all right, which does nothing but receives the message from the medium. And then the decoder basically changes the message from the signal or from the wave to human readable form. All right, and then it is displayed on the message destination. That's what happens basically. So you have a source. The basic idea is that you have a source. you have a medium, and then you have a destination. And between these, there's encoding that happens because machines or devices don't, or the medium, they don't understand human readable things, or uh, human readable stuff. They don't understand it. So it should be encoded into a form that is understood by the network, whether that's signals or waves, and then it should be transmitted over the network, and then the receiver receives it on the destination and then decodes the message for the person on the destination to basically understand the message. Now, another video. I'm going to pretend you'll go over to this particular video, watch it, and then come back. It's a 12-minute video, I think, but it is very, very useful. It will give you a very good explanation of what switching is and what are the different techniques. So again, pretending that you've completed watching the video, switching basically is, let's say, your network. So switching basically is trying to find the best possible path on the network from the source to the destination. So let's say there are many paths on your network, there are many connections on your network. Switching really means to find the best path between the connected devices. All right. There are many ways of switching. You must have seen those in the video, but we'll go over two of them. The first one is circuit switching. Circuit switching is nothing but it's a type of, let's say, switching in which the path between the sender, which is here, okay, or the source, and the destination is dedicated. What does that mean? That means that if this person was sending something to this particular device, this person should wait in order to communicate with this device, because there's already a communication that's happening between this source and then this destination. This is similar to, let's say, when you make a phone call to your friend and you're talking to them on the phone, but then someone else is trying to call you. They have to wait until you finish the call, or let's say you add them, whatever happens, but they are waiting, right? That's the same exact idea. They have to wait for you to finish the call so then they can call you and talk to you. So that is the basic gist of circuit switching. And the disadvantage of this is that, firstly, there are a lot of delays, because then if this person was trying to send something, it would take a longer time, because they would be waiting for this person to end their communication, right? So there will be delays. There's inefficient use of channel. That means that every path on the network is dedicated only for one communication, whichever one communication is established, or whichever connection is established, it can only be dedicated to that connection until the connection or the communication is over. And then a lost message is entirely retransmitted, which means, again, if something is lost, you need to send the whole message again. All right. That's circuit switching. The next one is packet switching. So what happens in packet switching is, it's also called segmentation, first of all, and then, which is really the other name for packet switching, it's called segmentation. What happens is your message, the one that you're trying to send, is broken down into smaller segments, which are called packets. Okay, and they're numbered. So let's say this package has number 0, this has 1, this has 2, and then this has 3. Okay, let's assume. So what happens is that these packets will have two things on them: the source address and the destination address. Each of those packets, along with this number that I just said. So what happens is all these packets will travel across the network, there is no dedicated path. So this person can send their message on the network, and this person can also send their message on the network at the same time. The packets will travel individually. Okay. What happens on the destination is that the destination receives all these packets and then reorders them according to these numbers that are given. So on the destination, it will reorder the yellow packets as 0, 1, 2, and then 3. All right. So it's just like how you send parcels. You always, there's always a source from where the parcel is sent and a destination where the parcel is being sent to. So that, an analogy fits the situation here. So the best uh, benefits or the advantages of segmentations are multiplexing, which means different transmissions can be, oops, sorry, different transmissions can be interleaved on the network. That means different transmissions can happen on the same network, just like how it's displayed in this image. You can send multiple transmissions on the same network. You don't have to wait. All right. And then there's reliability, which means that, we'll learn about how it's more reliable in the upcoming slides. So what happens when we break down break down messages into packets? The basic thing is that each piece of message can travel across different paths to the destination. So let's say this person is trying to send a message to this person. I'm, I'm, when I say person, I just mean device. Okay. So this device is trying to send a message to this particular device. In this case, it should be the destination, and in this case, it will be the source. So it generates a packet and it sends to all these devices that are in the middle, which is called the network. And each of these packets can travel differently. So maybe one packet, which is generated from here, takes this route. Another packet takes this route. Another packet would take this route. But all of them will reach the same destination here. Because, like I said, each packet has the source address and also the destination address. So finally, all of them would reach here, and then this particular destination device would reassemble them according to the numbering that was given. All right, so the benefit is that if, let's say, this particular path is, oh my God, one second. If this particular path is basically broken, okay, you still have this path that you can take for the packet. There's another path available, which is this one. So there is a lot, you can rely on the network. You don't have to always rely on just one path on the network. There are alternative paths that can be taken in case of failures or congestion. Congestion just means that if this path is already being used by multiple packets or something like that. All right. And what happens is, like I said, in the previous example, if we go back, here there are 3 packets. Let's say one of them was missing. One of them didn't make it. The third one didn't make it. What will happen is the destination will request only for the third packet. It won't ask for all the other packets that actually arrived. All right, so that makes it easier to communicate and less congested on the network, less congestion on the network. Okay, so that's what I said. Here it shows that if this link fails, it can still take other routes. Okay. So the only disadvantage of segmentation is that it adds complexity to your network, which means that the label is a unique number. So basically, the multiple pieces are labeled. So the packets that we just saw, they have, like I said, they have numbers, right? These numbers are basically used for reordering and assembly when they reach the destination here. And each of those numbers or labels, let's say, is a unique sequence number, all right? And they're handled by protocol that format and address the message. So the same thing, they're handled by protocols for reassembly and how that message should be formatted and displayed to the user. Now, network uses devices, media, and services. Devices are these, all of these are devices, right? All of these are devices. This is a device. Well, again, all of these are devices. There is media as well. Media can be considered as how you're connected to these devices. So in all of these cases, you're connected using cables. The black line just represents a cable, okay? Cable everywhere. And then services are just what you use on the network. All right, so like I said, these are the media, and then the services are what you use. So here, let's say on this computer, you are browsing. Okay, and then maybe on this is for streaming, like in the sense that you're talking to someone on the phone, and then maybe you are sending, this person is sending emails, whatever that is, you're using services on the network. Okay, now the first kind that we saw is our devices, right? There are many kinds of devices on the network. The first one of them is the end devices. End devices are basically workstations, servers, laptops, printers, voice over IP phones, security cameras, and PDAs. All of these are considered end devices. Why do we call them as end devices? Because they allow us to interact with the network. All right. End devices are referred to as hosts, and there can be either the source or the destination. We don't call them end devices when we refer to them in the network perspective. We call them as hosts, and that just means that they can be either source or destination. So in this case, let's say this is maybe the source, um, okay, and then this one, let's say here is the destination. Wow. Sorry about the writing, but it's I tried to write destination here, and I hope it's understandable. Okay, so what else? Okay, so basically on a network we have devices, media, and services, right? Those devices that we have on a network can be end devices, and there are other types as well. We'll look into that in a minute. But end devices are basically the devices that allow you to, like we said, interact on the network or communicate on the network. These end devices can be either considered as a client or a server. And how do you differentiate if an end device or a host on a network is a client or a server? It is based on the software that is installed on the device that allows you to determine if the host is a client or a server. Okay, so a client could be could be a host that has Windows 10 installed on it probably, or Mac OS, some version of Mac OS installed. But a server could have, let's say, Windows Server installed on it. Server is an operating system. Maybe maybe a host has the Windows operating system for a server installed on it, which makes it a server. Both of them are devices. They could be computers, they could be virtual machines, whatever that is. The software that is installed on it, on a host, makes it either a client or a server. A client could be any client, a host that is using any client operating system, and a server would be any device or host that that has a server operating system installed on it, or it is yeah, basically that's the gist. It should have a server operating system installed on it, and it can be used for multiple purposes. A server could be used for email. A server could be used for browsing web pages, all of that. So basically, that's the difference between a server. So like we said, end devices can be, or also called host, can be either a client or a server, and the difference is in the operating system installed within the client and the server. So, and usually the client basically connects to the server to get information or to request something. That is how it works. All right. Intermediary devices. By the term itself, we know intermediary means something or someone in the middle, right? That's exactly what these devices are. These devices are basically routers, switches, hubs, wireless access points, communication servers, and security devices, and many others. But these are devices that in the simple terms, you can say that these are the devices between the source and the destination. So let's say maybe someone is sending a message from here to here. So these are your intermediary devices, and they're between the source and the destination. But mainly, these devices allow you to connect on a network, okay? And they manage your network traffic. Network traffic. Oops. No, 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 wait. Traffic. Okay. Like I said, they manage the data as it flows through the network. And some use the destination, host address, and network interconnection information to find the best path through the network. So essentially, that's what they're doing. They're managing your messages or packets that are flowing through the network, but they're also trying to find out what is the best path for your message to reach the destination. So let's say you're sending a message from to someone from here. Like for example, this person is sending a message to this person. These devices in the middle will figure out which is the perfect path to take to reach this particular, you know, destination. They also figure out if, there's a failure in one of the links. So maybe let's say this link is not working. So this router knows that, okay, this link is not working. So, take another path. Things like that. All right. So these are some of the intermediary devices: routers, access points, hubs, switches, firewalls, and multiplexers. So they regenerate and retransmit data signals. So the signals or the waves or whatever that is that come from the source, these devices, they regenerate and retransmit it to the next point or whatever next device is. They maintain information about the pathways that exist through the network. So they know of what paths are existing on the network. And they also know when there's a communication failure or an error on a device. They can figure out, and based on that, they can create alternative paths for data to flow in case there's a failure in one of the links. So like I mentioned before, let's say there are four paths between these intermediary devices. If one of them fails, the routers would know that this is a failed path. So what they would do is they would flow the data using the remaining three paths. All right. They can also these Devices also classify and direct message according to the QoS priorities. What does that mean? That remember the quality of service priorities that you have on a network. These devices, they can classify the packets or the data that is coming in based on those priorities. So let's say someone is requesting an email service, someone is sending streaming data, or someone is sending a browsing request or something like that. These devices will figure out, okay, which one has the highest priority, send that one out. Okay, things like that. And these can also permit or deny the flow of data. So that means you can set passwords on these devices. You can block paths, permit or deny paths using these devices, so they can you know implement the security on your network as well. Just like how your router at your home, the Wi-Fi router would have a password, right? So it protects your network that you have. The next thing that we looked at was media. The first one was devices, the second one was media, right? So media also has different types. We have copper cables, usually Ethernet cables. We have fiber optics. These are very expensive, but these are usually the ones that are used nowadays. And then you have wireless as well, right? So these are the different types of media that are available. But how do you, and usually these mediums, they allow you to transmit the data. So the data is converted to binary, or yeah, converted to binary, and then the signals are generated. Those signals are basically transmitted through these media. So there are metallic wires within cables, just like how it's shown here. If you take a closer look on this picture, there are metallic wires in the cable, and then the fiber optics are basically glass or plastic fiber, and then wireless transmission, we probably all know about this. Now, you can use different media on your network, but what differentiates one medium from another? It's basically the purpose. The purpose defines which media you should be using. So let's say you want a connection in your home only for your family. Let's say you need a Wi-Fi, not a Wi-Fi, but like an internet connection in your home. You wouldn't go for Ethernet cables for everyone, because everybody's probably using different devices. They're either using laptops or PCs or tablets or phones. So in that case, the best idea or the ideal connection would be wireless. But the problem with wireless would be that it wouldn't expand to a large area, right? So if you want connection on a campus, the better approach would be to probably also have wireless, but then in addition also have copper connections. Like on the campus, you'll see all the devices on the campus are connected using the Ethernet cables. So that's a good option because these cables are cheaper than the other options, and they provide you a connection that can expand to a large area. But fiber optics are probably faster, right? So in that case, if you want fast connections um, or things like that, you would opt for fiber optics. So again, the purpose defines which media should be used. And these are some of the, let's say, variables that can define which media you should be using. Distance, let's say if they're using wireless, the distance is absolutely should be small. It shouldn't be a huge campus for wireless. And then the environment, maybe it's a hilly area, or maybe it's an area where there's a lot of snowfall, or something like that. So and the environment also plays a crucial role in that. The bandwidth that's required, the cost of the media. So fiber optics are really expensive, but copper cables comparatively are cheaper. And then installation costs, costs of connectors and everything. So all of these play an important role in deciding which media should be used. LANs, WANs, and inter networks. So a LAN is basically the short for local area network. So it's called local area network. What it basically is, it's a network that spans over a single geographical area that provides services and applications to people with a common organizational structure, such as a business or a campus or a region. That means that you have one network, one single network that is expanded on one geographical area. So let's say the Polytechnic campus has one LAN, a local area network. And local area networks are usually for people that belong to the same organization. So the people that are in Polytechnic, whether they're staff, students, allied staff, other people, they're able to use the network that is provided by the Polytechnic. Similarly, there could be a business that has, their own local area network. There could be a region that has its own local area network. So local area network is a network on a single geographical area where people can connect to the network, and these people belong to the same organization. Now, wide area network is, you can think they're like multiple local area networks that are connected together. So, but the catch here is that these local area networks are in different or are separated geographically. So you have multiple local area networks that are separated geographically, but they're connected together to form one wide area network. An example for this could be that, let's say you have a company or an organization that has one of its office in Bahrain, one of its office in UAE, and one of its offices in US. So they have different in each of those locations. They have their own local area networks, but because it's one company, they probably want to connect with the other offices as well. So in that case, you would connect all these three local area networks using a wide area network, and these are usually done by telecommunications service provider, TSP, through a leased connection. Um, a TSP traditionally transports voice and data on different networks. Now providers are offering converged network services, like we read about this in chapter 1, I think. Usually there were different networks for different purposes, but now we're seeing that we have a converged network, which means through one network, many kinds of devices or many kinds of media can be connected. Now, what is internet? Internet is nothing but network of networks. So what it ideally means is that you have, like I said, let's say Betelco, for example, has their own network that allows their customers to connect with each other. Similarly, Zain has its own network. Likewise, STC has its own network. When all of these vendors, or not vendors, but all of these providers, when they connect their networks together, that becomes the internet, meaning that now all the customers can connect with each other because these providers have connected their networks together. So internet is nothing but multiple ISP providers or IS providers, uh, you know, cooperating with each other to form one large converged internetwork. So when they connect their infrastructures together, one converged internetwork is formed. Again, these are some of the network representations. We've seen this before, but we have a router, a LAN switch, a LAN hub, a server, a desktop computer, a laptop, wireless media, LAN media, WAN media, wireless router, wireless access point, IP phone, firewall. Now, all of these are, this is how these devices show up in packet tracer. So it would be nice if you can familiarize yourself with this. But yeah, these are the representations for the network devices that we have. There is something called network interface card. It is nothing but a card that provides you a way to connect to a network. It is usually the place where you can plug in the Ethernet cable, and it just allows you to connect to a network basically. We have physical ports as well, a connector or outlet on networking device where the media is connected to a host or other networking device. So you usually have a networking device, which are the intermediary devices usually. They have these ports. If you can notice here, they have these ports on them. You can even check your Wi-Fi at home, the Wi-Fi router. It will have these ports on its back. Now, these ports allow you to connect for example, you can connect a wire, which is a media, any wire, or a cable, and that cable would then connect to a host, if that makes any sense. So, for example, you have a router, all right? Let's assume this is a router. On its back, it would have these ports, okay? In these ports, you can plug in a medium, which is a cable or anything, and then that cable would then connect to another, let's say, another networking device, or let's say it can also connect to a PC or a laptop or whatever that is. I'm so sorry for these drawings, but I hope this makes sense. So in this case, this is the media, this is your host, and then this is a networking device or intermediary device, the same thing. And this is basically, let's say, the router or the router. Okay, so physical port is a port that allows you to connect this particular networking device to another networking device or to a host, which is an end device. All right, and then you have interface. These are specialized ports in an internetworking device that connect to individual networks. So the next thing that we have is interface. Now, on a local area network, your router, let's say I'm going to use the circle symbol for a router, is used to connect to other networks. What does that mean? That means one of your routers on your local area network will be connected to another router that is on a different local area network. So let's assume this is a different LAN. Okay, and then this one is a different LAN. Similarly, any internetworking device means the devices that allow you to connect networks together, such as routers. So any internetworking device has these interface ports. These interface ports are basically the ports that allow you to connect to other networks. Okay. So just like how it's stated here, because routers are used to interconnect networks, the ports on a router are referred to as network interfaces, protocols. So now we stop here and then you watch this video. It's a good video. It will help you understand a lot. Just go and watch the video, and then once you're done, you come back